The topic is about drift and diffusion current in PN junction diode. Before we start that, the conduction in intrinsic semiconductor at room temperature, the electric current in a metal, also called drift current, is due to free electron movement is J equal to Qn nu E. I is the current density due to the movement of electrons only. So Jn is Qn mu n E, where Q is the charge of electron, N number of electrons, mu n mobility of electron, and E applied electric field. The same when we go for p type, Jp equal to Qp mu p E, where Q charge of electrons and holes, P number of holes, mu p mobility of holes, and E is the applied electric field. So the total current density is J equal to Jn plus Jp. So it is Q into N mu N plus P mu P into E, which is rho into E. This is the conductivity of semiconductor. So Nj equal to Q Ni mu N plus mu P into E for intrinsic semiconductor. Conductivity rho equal to Q N mu N plus P mu P. So the conductivity rho for N type, when N is greater than P, number of electrons is more than P, rho equal to Qn mu N, and for P type, rho equal to Qp mu P. Mass action law states that Np equal to Ni square. The number of free electrons into number of holes is equal to the intrinsic carrier concentration square. The charge densities in N and P type, take Nd is the concentration of donor atoms, that is an electron is donated, so a positive charge is created. It's contributed by the donor ions. P the hole concentration, number of holes per meter cube. Na concentration of acceptor atoms, that is negative charges. So when an acceptor atom is there and it moves, a negative ion is created, and N free electrons. So total number of positive charges per meter cube is Nd, number of donor atoms, since negative ion, positive ions are created, plus P, number of holes. Total number of negative charges is Na plus N, and by charge neutrality, Nd plus P equal to Na plus N. In N type of semiconductor, when the number of electrons is much higher than the number of holes, Nd equal to N. And in P type of semiconductor, Na equal to P. And we know by mass action law, Np equal to Ni square. So P equal to Ni square by N, and N is the number of free electrons, which is the number of donor atoms only. So P equal to Ni square by Nd. Same way when we go for P type, N equal to Ni square by Na. Take Nn is the number of free electrons in N type, number of holes in N type, electrons in P type, and holes in P type. We can write Pn equal to Ni square by Nn or Ni square by Nd, and Nn equal to Ni square by Pp or Ni square by Na. So if equal concentration of donor atoms and acceptor atoms are added to intrinsic semiconductor, it remains an intrinsic semiconductor. If more donor atoms are added than the acceptor atoms to an intrinsic semiconductor, it becomes an N-type semiconductor. Force by mass is equal to QE by M. Drift velocity is mu E, where mu is QT by M. Now we come to drift current. The same which we have seen, when a small amount of electric field is applied across a semiconductor bar, the electrons and holes moves from its place, which contribute the electric current. The current due to the holes Jn is Qn mu n E ampere per centimeter square, and Jp is Qp mu p E, and the total current is the sum of both. And conductivity is Qn mu n plus Qp mu p. And we have the data for N type and P type. Now when we go for diffusion current, it is the movement of charge carriers from high concentration region to low concentration region. So as X increases, the concentration of the holes reduces here, and so the formula is Jp is proportional to dP by dx, where dP by dx is the concentration gradient. Jp equal to minus Q dP dP by dx. This is the diffusion current, minus sign, because as X increases, the concentration hole reduces. It is inversely proportional. So this minus sign. dP is the diffusion constant, and dP by dx is the charge gradient, concentration gradient. And same way we have dN equal to Qn mu n, Q mu n in dN by dx. So Jp equal to total drift current equal to this current, total current because of holes is drift current plus the diffusion current. So it is Q mu P P E minus Q dP dB by dx, and the total current for N type is Jn equal to Qn mu N E plus Q dN dN by dx. So in both we have the drift and diffusion currents added. We also have the Einstein relationship which states dP by mu P equal to dN by mu N equal to kT. We know dP diffusion constant, mu P mobility of holes and electrons, K Boltzmann constant, and T temperature. So carrier lifetime states that the time for which on average a charge carrier will exist before recombination with the carrier of opposite charge. So the time for which frequent movement of charges, electrons and holes happens. So the time for which it waits before recombination is called the carrier's lifetime. The value is from nanoseconds to hundreds of seconds or microseconds and depends on the temperature and the impurity concentration in semiconductor. This is about the drift and diffusion current. Thank you.